Hello everyone, welcome to RN tutorials on engineering mechanics. So in this video lecture again we are going to discuss about applications of friction that is related to ladder problems. So another model of example I am going to explain how to analyze the friction and how to find out the required term that is related to the friction in between the ladder and the floor or otherwise a wall here. So in this video the question is given like this: a ladder 5 meters long rests on horizontal ground and leans against a smooth vertical wall. So here I would like to take a floor and a wall. Okay, so the ladder of 5 meters long is resting on a floor and it leans on a smooth vertical wall. So he has again mentioned the wall is smooth, so there is no friction in between this ladder and the wall, so the friction is zero here. So we need to analyze for the contact point between the ladder and the floor itself here. And this ladder is making an angle of 70 degrees with the horizontal, so angle of inclination, and here sorry, so the length is 5 meters and the angle of inclination is 70 degrees here. That is 5 meters long ladder rests on horizontal ground, that is floor, and leans against smooth vertical wall at an angle of 70 degrees here. And the weight of the ladder is 900 newtons here. So the weight of the ladder acts exactly at the middle position of the ladder, vertically downward direction. The value is given as 900 newtons. Okay, and it is again mentioned here, acts at its middle. Okay, and the ladder is at a point of sliding. So here it is at a point of sliding, means if the weight increases more than the forces are acting, or weight or forces acting on a ladder increases more, so automatically the sliding of the ladder starts. But here not at sliding, it is at a point of sliding here, so still it is in equilibrium condition only. And again a man weighing 750 newtons stands on a rung. So the ladder consists of number of rungs which act like steps to climb over it. So here a man is standing on one of the rung who is weighing 750 newtons and at a distance of 1.5 meters from the bottom of the ladder. So over the ladder at a distance of 1.5 meters, a man is standing with a weight of 750 newtons. Okay, and we need to calculate the coefficient of friction between the ladder and the floor. So with this given information we need to find what is the mu value, coefficient of friction, we need to find out with the help of this given data. Okay, so with this data we try to find coefficient of friction. So before that we need to analyze the direction of the force of friction. Already I have mentioned the direction of force of friction because it is at a point of sliding. Even these two forces are acting, it is at a point of sliding only, but not at sliding, it is over the floor. So when it is trying to slide, automatically this force of friction opposes the motion. So we can assume that this force of friction is stopping the ladder to slide over it. So that's why this ladder is in equilibrium condition. So the force of friction acts opposite to the motion in which direction the ladder is trying to move. That is the motion it has to take place. So again the wherever the force of friction is acting, we need to mention the normal reaction, which is frictional reaction, that is RF, which acts vertically upward direction to the ladder at a contact point between the floor, that is the ground, and the ladder here. Okay, so by representing these two we can go for the problem solving procedure here. So before that I have given the names for the ladder AB, and the corner point of the ground and wall I have given as a C point. So these can be helpful while solving the problem. And here first we need to consider, as usual, the first step is I want to consider vertical forces which are acting on the ladder here. So how many vertical forces are acting here? Just try to observe here. RF is the vertical force, reaction force, which is due to the friction acting vertical upward direction on the ladder, and one is the weight of the man who is standing at a distance of 1.5 meters, and the weight of the ladder, which is 900 newtons, which is also acting vertically downward direction. So total three number of the forces are acting in vertical direction. So here 750 and 900 both are in same direction, and RF is in opposite direction. So according to the equilibrium condition we can write sum of all the forces can be equal to 0, or here opposite forces can be equal, we can write it as. So RF is equal to, we can write it as sum of the two opposing forces to RF, that is 750 plus 900 newtons, which gives you 1650 newtons of the normal reaction, which is due to the friction in between the ladder and the ground we can get. So that is the value RF. So next we can go for taking the moments of the forces and weights about B and apply equilibrium condition. Here for solving the problem we need to take the next step as taking the moments of the various forces and weights acting on a ladder, and we need to apply the equilibrium condition to get the required value mu. So before going to find out mu, first we try to find out ff, then we can easily go to finding the easily we can find the required value mu here. So in this statement I have mentioned we need to take the moments about B. So about this B point we try to take the moments here. So first I would like to explain again. We can write it as the moments when the body is in equilibrium condition. Here the moments in anti-clockwise direction is equal to moments in clockwise direction, vice versa we can write. So first I would like to consider RF, which is causing the anti-clockwise motion here. Okay, here this RF is causing anti-clockwise motion. So this RF moment with respect to B point, this is the respect to B point. From the B, if you draw a vertical line here, it will be over the wall only. So to this vertical line we need to take the perpendicular distance. So to briefly understand, we need to take the distance AC to get the moment of RF here. So RF into AC will give you the moment. Okay, so that AC how will you get means, if you construct a right angle triangle ACB here, so this AC we can find out by knowing the AB and BC here. Otherwise directly by knowing the angle 70 degrees also we can find. How we can find out, I'll show you here. So for this right angle triangle we know the AB length as 5 meters and 70 degrees as an angle. So this AC how can we write it as, if it is a right angle triangle we can write this one as 5 cos 70 degrees. Why? Because cos theta is equal to adjacent by hypotenuse. So adjacent is equal to, we can write it as 5 into cos theta here. Okay, just like resolving the forces. So by right angle triangle we can write it as AC as 5 cos 70, and similarly BC we can write it as 5 sin 70. So actually to find the moment of RF we need the perpendicular distance, that is AC. AC is equal to, it is 5 cos 70 degrees. So RF into, we can write it as 5 cos 70. So which is causing anti-clockwise. And again carefully observe here, FF and these two weights 750 and 900 newtons are causing the clockwise rotation. With respect to B point, when you consider this force of friction, it tries to rotate in anti-clockwise. Okay, sorry, here RF is clockwise direction, I told you it is anti-clockwise. Sorry, the RF is clockwise direction, and FF and the 750 newtons and 900 newtons are causing anti-clockwise rotation. So the clockwise rotation is equal to anti-clockwise rotation, we can write. So this RF is causing clockwise and these remaining three are causing anti-clockwise rotation here. So this can be equal to, we can write it as sum of all these moments which are causing anti-clockwise rotation here. So is equal to, we can write it as, first I want to consider FF. So this is the force of friction FF, okay, which is causing anti-clockwise rotation of the body into perpendicular distance. Means if you try to extend this FF over the floor, so perpendicular distance becomes BC here. Force into perpendicular distance gives us moment. So this FF into BC becomes the required moment of the FF force of friction. So FF into BC means, what is the value of BC? 5 sin theta here. Okay now, so FF into 5 sin 70 we can write it as, and plus what is the next force? We have to consider 750. So for this 750 again we need to take the moment. So force into perpendicular distance, the perpendicular distance between the B point line and the force of action, that is the weight of action of the 750 newtons. So what is the perpendicular distance? Means again if you construct a line here that is perpendicular to the BC, which is the vertical line from B, Again we can consider right angle triangle by the shape itself. So angle of inclination is again equal to 70 degrees only here. So this line, adjacent line for the right angle triangle, we can write it as, we can write it as with the help of 3.5 length of the remaining portion of the ladder here. This right angle triangle, we have to know this length. If you know this length, we can write the adjacent length here. So here this becomes automatically 3.5 cos 70, like this ACB. Similarly, with the help of B and this contact point of the weight and this line, we can consider right angle triangle. So adjacent side can be equal to 3.5 cos 70. So that is only the perpendicular distance. So we have to multiply the perpendicular distance to 750. That is over, and plus the remaining weight is what is the remaining weight? Remaining weight is 900 newtons, and perpendicular distance, again if you draw a line perpendicular to BC vertical line, automatically the length of that line becomes the perpendicular distance. So that perpendicular distance, again we can write it as, by considering a right angle triangle from B to midpoint of the ladder to this required line here. So this angle is again 70 degrees only, and this point 900 newtons is acting exactly at the middle position. So automatically the remaining length becomes 2.5. So this adjacent side becomes again 2.5 cos 70 degrees from the right angle triangle construction only. So the perpendicular distance is 2.5 cos 70. We can write here 2.5 cos 70 degrees. So over all the forces we have considered for writing the moments. So here clockwise is equal to sum of anti-clockwise. Sum of clockwise forces, moment of forces, is equal to sum of anti-clockwise moments of forces we have written. So I would like to produce this same step in the next slide. So this equation we need to modify. So I would like to write force of friction into 5 sin 70. So this is equal to 500. Why? Because we need to find force of friction only here. So that is equal to, we can write the remaining terms, or otherwise you have to take all the remaining terms to the left side. So RF means already we know 1650 into 5 cos 70, as it is 5 cos 70 we need to write, and again 750 into 3.5 cos 70 we have to take it to the left side. So automatically here I am writing right side, that becomes negative, and the same term, and this positive term again when it goes to the left side, again it becomes negative term. So as it is, we have to write the remaining term also. And in the next step again we can modify the equation. So when you modify this entire term with help of the calci, we get the value as 1154.317 divided by, as it is, try to write 5 sin 70 degrees. Again modify this equation, then FF is equal to, we get the value as 245.68. So use the calci and calculate the value. Automatically the force of friction we get 245.68 newtons. So this is the force of friction. So we have determined the force of friction with the help of the weights and the reaction force we have determined with the help of the data. Next we need to go for finding the required term, which is the coefficient of friction. So for finding the coefficient of friction, we already know the general formula for force of friction is equal to coefficient of friction into normal reaction RF. Force of friction we have determined, mu F we need to find out, and RF already we have determined, which is 1650 newtons. So try to substitute those values in this equation otherwise try to modify here. Mu F is equal to, we can write as, how can we write it as, FF by RF. So automatically try to substitute 245.68 divided by 1650. So mu F, the value we get it as 0.1488. So approximately we can write it as 0.15 is the coefficient of friction. So which is the required term as per the problem is given. In the problem he mentioned to find the coefficient of friction only. So by finding the force of friction we can find out the coefficient of friction. So I hope you understand how to find out the coefficient of friction by analyzing the forces and their moments. So once again, thanks for watching my video. Thank you all.